Okay, we've got an experimenter that wants to determine the frequency of oscillations of a mechanical oscillator by using that mechanical oscillator to set up standing waves in a string. And the thing is, she wants to get an accurate value for mu by measuring a mass and a length while the thing is stretched. So that's this business of making the two marks a certain distance apart while it's stretched about the amount that it's going to be stretched when she actually does the experiment. But she found she probably did it once, got this value, the 65 newtons, and then when she did the actual run that she's taken the data from, it was slightly over 65 newtons, but within the uncertainty, so not very much over. So we're going to be working with the length of it while it's got a tension of 65 newtons. So might not be perfect, but it's better than just using a length when it's not stretched at all and finding the mass of it. So she's doing a little bit better than what she would be doing if she didn't try to get the length while it was stretched at all. So the length L, I think I'll leave this part alone over here. So the length L is given as 1.350 plus or minus, and that 2 is in this digit, so that's 0.002 meters. Alright, and the mass she gets is this value. We can convert that to kilograms. That'll be 0.004022 with the uncertainty in that last digit, kilograms, or the little mass is I think I'll need more room for that. Okay, it's this digit right here, which is 1, 2, 3, 4, 5 zeros, and then the 2. So 3, 4, 5, 2, and the units there, kilograms. Alright, that will be her expression to get the linear mass density. She'll be needing these two values. And then alright, she actually sets it up, does the experiment, gets a nice standing wave in there with 3 antinodes, about like that, measures the distance, I'll call it L, between 2 antinodes, 2 interior nodes. The 2 interior nodes, there are only 2 interior nodes, so she measures that distance L, and we can see that that's a half a wavelength. So I'm going to write a half a wavelength is equal to L, or lambda is equal to 2L, where the little l is 0.295, and then this digit is the one that this one corresponds to, so that's 0.007. meters for the distance between nodes using this string. It's got the mass per length, which is mu, which is this value divided by that value. Okay, and she gets that distance between nodes when F sub t is 65.020 newtons. With the mu here and the F sub t, we've got enough to calculate the velocity. Here's where I'm going. We get an expression for the velocity. We can think of it as a value for the velocity, but if we get an expression for the velocity, then we can simply use the velocity is equal to lambda f solved for f in order to answer the question. So at this point, I want to use the fact that the velocity, you can look at it on your formula sheet, it's given as f sub t, the tension in the string, divided by the mass per length, or I'll substitute for the mass per length. That would be m over the capital L. And I think I'll substitute for the velocity at the same time. That's lambda f. So I'll pure substitution to 2 at once, though. And so f is given by 1 over lambda times the square root. But we just found the wavelength lambda to be given as 2L. So I can say f is given as 1 over 2 little l times the square root of f sub t divided by m over l. So I'm going to substitute values in there. I think I wrote them down for the most part along the way. So it's all these values. I think I'll go ahead and copy and paste these guys. So Control C, and then scroll down here. Control V. I need that guy in there. I need the tension, the little m, and this one. I think I'll go tension, little m. Got this. Control C. Control V, put the little m over here. And then the tension was given as this expression. When I hang that much weight from it, it's going to create that much tension in the string. So 65.02 plus or minus with a 50 there. F sub t and it was these two digits affected by the 50, so it would be 0.050 newtons. And what else do I need? The little l. Actually got that out front, so I think I'll put that first. The little l, I did write that down here, so alright, I think I can get rid of that. So I'm evaluating this expression right here with all these values up here. I'll do it on the calculator first. So F is equal to 1 over 2 times the little l is 0.295 meters. Then times the square root F sub t, 65.02 newtons, divided by, and I should have parentheses around that to make it clear what gets divided first. The m is 0.00422 kilograms, and the capital L is 1.350 meters. So let's get a numerical value for that one first. Let's see, I want to scroll around a little bit. And here we go. I'll go out front. I got in parentheses. I'll put it 1 divided by, again in parentheses, 2 times 0.295. Close the parentheses for the denominator, and then close for the whole expression. Then times the square root of 65.02, all divided by open parentheses, 0.004. It says 0.00422, but I'm not sure I believe that. It's 0.004022, so 0.004022. Can't quite read that, so let's fix it up. Alright, 0.004022, and then slash 1.350, and I gotta close the parentheses for this thing in the denominator, and then the other closed parentheses that was already there is for the square root. So I think I'm all set. So I got something wrong. Times the square root. So this is good up here. Then times the square root of all that stuff, and I'm not really seeing any error. So let's try. I think I'll pick a piece of it out here if I can. No, 1 slash. I'll go last. So I decided to go open parentheses 1 slash 2 times the 0.295, and then close parentheses. I wanted to put this part of it in parentheses, so I'll do that, and then close the parentheses for the whole thing. Oh, I see what it is. I left out the times right there, so I left out the star. So I'm going to go ahead and clear this. If I double click on that, I get the expression that I had, and I'll put an asterisk in there. Just hit the times button and see how that goes. Yeah, that looks good. So I'm getting F is equal to 250 something. I call it, we're going to do the full error analysis. I'll just get the ballpark figure here. F is equal to 250, and then I got to work out the units. That's a kilogram meter per second squared. Sorry, kilogram meter per second squared. So let's see, the kilograms cancel out there. I got meters in the denominator here, so that's like meters squared up tops. So I got meters squared over second squared. Take the square root of that. I got meters per second times meters. I got 1 over seconds, but 1 over seconds is the same thing as hertz. So I got hertz for the units here for the frequency. So now we just have to fire up GalCP, see if we get the same thing for the main thing, and we'll get the error analysis as well. So I want to analyze this function right here using GalCP with these values. Let's go ahead and find GalCP. Fire up a browser. I'll go CB Physics. PHYSICS. There it is. First semester downloads, math resources, GalCP. Open that up. Double click. Open. Alright, I think I'm over here where I'm typing in my name. And then I want to get the number of variables right. So yeah, 1, 2, 3, 4. 1, 2, 3, 4. That looks good. So I'll type in 4 variables. Let me get rid of that and that. Type in 4 variables, And the thing I'm solving for is f. That's not what I wanted. There we go. I wanted to be able to make this a little bit smaller so I could see what I was doing. So I'm solving for f. That's good. The name of my function is already f, so I'll leave that the same. And then x1, double click on that, change that to a lowercase l, hit return, lowercase l, hit return. I got to look here to see what that is. Scroll up a little bit so I can see it. 0.295. I think I'll be able to see it while I'm typing that in here. So 0.295, return 0.7. That was for the little l. And then the next thing in my formula was, I actually got to scroll down here a little bit. F sub t. So the next thing I'm calling it f sub t. I'll just go f capital T, hit return, call it f capital T, capital both, 65.020. Return 0.05. Return. Okay. The third variable is m, little m I've got, so I'll call it, double click on it, hit m, return, m, return, and m 0.004022. Return in point, that's 2, 4, 5 zeros and a 2. 0.12345 and a 2. Return for the mass. Okay, then the fourth variable is capital L. I'll double click on it, hit L, return. It doesn't like that, so I'm using capital L, but I'll go LL. Return, LL, return. And down here, I'm finding that it's 1.350. 1.35 is good. Return, and then 0.002. And I'm worried, did I ever change the... Yeah, I got 4 variables there, so I did take care of that. And then in here, I just got to type in what the formula is. I'm going to hit the equal sign. Like I'm going to start all over. So equals, I'll go open parentheses, 1/2 times, and then the little L is right there. Just click on it, hit return. I wasn't supposed to hit return yet, so no, I don't want to accept that. I don't know what's going on. I'm actually going to start over on this one. I'll hit return for that whole thing. And go equals 1, or open parentheses, 1/2. I want this bottom part in parentheses too, so I'll go open 2 star. This time I'll just click on the little L, not hit return, and then go looking at the rest of the formula. Close the denominator, close that whole expression out front, hit the times key, which is what I forgot to do with the calculator, and then times the square root, SQRT, of, and then it's f sub t, so I'll go to that one, f sub t, and then slash, open parentheses for the denominator down here, this lowercase m over L, so I'll go m, actually I got to get to the value, and then slash the big L, close parentheses for the denominator, close parentheses for the square root, and see if that comes out to 250. Yeah, that's the same thing I was getting on the calculator, 250.3902. Very cool. we're in good shape then. So just got to copy this down to the rest of them. I think I'll make this a little bit bigger. I'm going to go, so you can see what I'm doing, edit, copy. Alright, now I click on this first one. Then I'm not clicking on that little square. I'm going to go all the way over here to the scroll bar, scroll all the way down to the last one. Press the Shift key, and while I'm holding the Shift key down, click on this very last one. So I got them all selected, and then I'll do an edit paste, and it pastes that one value into all of those.